Megan.
I'm Alicia, and our other partner, Davey, cannot be here today due to some technical difficulties. We are Lefty EQ, and our project is based around designing and fabricating compact, foldable pet stairs set forth by our industry advisor, Gabrielle Shoshen. Given the product needs and objectives that she set forward, since pets are prone to injury from jumping on and off couches, beds, out of cars, and the current design for pet stairs are too bulky, heavy, and large to be stored efficiently. Since Gabrielle lives in a small New York apartment, she set forth these parameters in order for us to design and fabricate pet stairs that would best suit her needs for these storage efficiency problems. The pet stairs needed to be collapsible into 3 inches for storage, 24 inches in height, so that way it can be used for beds, couches, and cars, etc. The pet stairs should also weigh between 5 to 10 pounds, and it should support up to 250 pounds. The pet stairs should also be convenient for large and small pets to use, but also be cheap and easily manufactured if she wanted to go ahead and mass manufacture these products. So how we approached these needs and objectives is that the ME team came up with this design on your right through SolidWorks, which is a computer automated designing software. Based off of this design, our team was better able to narrow down materials that would best fit the needs for this design. It was decided that the material for the steps would have to be a material and probably a polymer that would have a high melting point. It should have good flexural and compressive properties and also have resistance to deformation, but also be lightweight in the process. The materials for the steps being considered and are tested are PVDF, PEEK, and FEP. These materials can both be injection molded and 3D printed, which is the most common type of manufacturing methods for polymers, and it's also the cheapest relatively. So if Gabrielle wanted to go ahead and mass manufacture them, these would be the best materials to use. A hollow frame was also added to the design in order to make it more lightweight and meet those weight requirements that Gabrielle discussed. We use an aluminum 661 frame because the material itself is easily accessible. It's strong while also being lightweight. And here are the prototypes that ME was able to come up with for given the time restrictions. As you can see, it's that aluminum frame I was discussing. Unfortunately, the blue steps that you see in the pictures and the video are not the material that we would like to use. It's an ABS plastic that they were able to 3D print. It doesn't have the same properties that we'd like, but we'd like to go on and use the materials that we tested that Megan will be talking about.
The first testing our group decided to do was compression testing. Compression testing allows us to see the material's ability to withstand a force pushing down on it, like the product would experience when animals are using it. To interpret the results, the strain, which is the deflection of the material, was plotted against the stress, which is the force per area. Normally, a sample is tested until failure. However, due to the load restrictions of the machine we use, the samples were tested until they reached the max loading of 6,500 pounds. FEP, which is in blue, underperformed compared to PEEK, which is in red, and PVDF, which is in green. The PEEK samples showed the least amount of deformation, and this means that they didn't experience as much strain as the others. Next, our group performed bend or flexural testing to understand the material's ability to withstand a force while experiencing bending. PEEK, which is shown on the left, showed higher stress values and lower strain values than PVDF did. This means that PEEK was better able to withstand this loading. Testing was performed until the sample experienced a 5 millimeter deflection. Unfortunately, the FEP data was saved incorrectly and could not be accessed. Continuing on, we were able to do DSC testing, which looks at the temperature properties of the material. To ensure that the material would not have a change in properties if the product was left in a hot car, we examined their behavior at 150 degrees Celsius. PVDF, which is shown in blue, would be too close to its melting temperature to be safely used. PEEK, which is shown in green, had the highest melting temperature of the three and would be the safest to use. PEEK, however, would reach its glass transition temperature range and would fail in a brittle manner as a result. This is not ideal. However, these high temperatures should not be reached as the car only hits around 60 degrees Celsius on a really hot day. Unfortunately, due to the circumstances, this was as far as we were able to get with testing, So we recommend running the following test. Running tests of the completed product with animals to ensure they feel comfortable using it. Running wear test on the steps and the frame to see how many times they can be pushed in and pulled out before they fail. Run testing on the foam inserts to ensure their properties. And to test if the nylon will work as a sufficient material to cover the risers and the steps.
Thank you. All right.